So let's talk about various approaches to solve a problem where we check whether S contains all the characters of T. It can be in any order. So basically, we are talking about whether S covers T completely or not. Now, if we talk about first approach, let's see, can we somehow apply sorting and solve the problem? If we think of sorting based solution, so first string after sorting, if we notice, it will become AA, triple A, then double B. Then we have C, D, L, double O, S, T, T. So this becomes first string after sorting. And second string after sorting will become double A, S, T, T. Now these are the two strings available to us. If we have to check whether T is covered in S or not, what we can do is we can essentially start comparing one by one, which we call as two-pointer technique. Now, if you notice, character of T matches character of A. If this happens to be the case, if two characters are same, what we do is we can move our both pointers. Now again AA matches. What we can do is we can again move our pointers. Now if you notice, this S isn't found in this character S is not found in the first string. In such case, we should wait. J pointer should wait here and I pointer should move above. Now B is not matching, so again I should move. Again not matching, I should move. Again not matching. As long as it is not matching, I pointer will continue to move. But now if you see S matches, because S matches here, both I and J should move. T matches, both I and J should move. And then T matches, both I and J should move. And the moment we come out of the second string, we say we are done. So this is first approach. If we talk about this is sorting plus two-pointer technique. If we go with this idea, and if we assume first string is of length Sn and second string is of length Tn, then first what we are doing is assuming this string is kind of character array and it is mutable, we are doing analysis with that. If you sort the first string, the time complexity of that will become Sn log Sn. If we sort second string, it becomes Tn log Tn. And after that, when we are traversing both the strings, that will be Sn plus Tn. So this would be our first approach to solve the problem. And in case we are solving the problem like this, considering string is mutable and we are able to change the order of the characters, space would be constant. If string is not mutable, we will have to convert string into char array, S into char array, T into char array, and that would end up becoming additional space, additional Sn plus Tn space. Okay, let's talk about another approach. Yeah. Another idea that we proceed with is, let's say we are not sorting the string, but let's still try to do a brute force. So our string S is ABA, CTO, DB, SATOL. And second string is ASTAT. Let's say we try to match A with character A in first string. So the moment we find a match of this, let's say we go and cancel out that in string S, we replace this character somehow with, let's say, dollar. So this is why we are doing this is to avoid matching it against another array. Now let's move on to next character, which is S. Start searching in first string. And the moment you find S somewhere, replace that also with dollar. This is done. You take a T, keep going left to right. Wherever you find T, replace that with dollar. Again, take A, you find a match of A here, replace that with dollar. You find T, replace that with dollar. Replacing ensures that we are not matching same character twice. So this will take care of the frequency. So if we go with this idea, if we go with this approach, then this is kind of a brute force. For every character in T, we are looping over every character in S to do a match. We can call this approach also kind of a brute force approach. And this would be Sn into Tn. And considering strings are mutable, we say the time complexity of this is Sn into Tn and space is big of 1. Let's talk about next approach. What if we take count array for both the strings? And count array is kind of an array of size 26. So this is count array for S. Let's also build a count array for T. These are both 26 size arrays. What we do is we first loop over the first string, which is S, and we build the count array. So in the count array at index 0 for A, we will say A is occurring 3 times. So we can assume this is count array for S. This is character A. Same way B occurs twice. Now C is occurring 1 time. D is occurring 1 time. And same way, continuing, somewhere L is there, L occurs 1 time. Then O is there, O occurs 2 times. Same way, somewhere S occurs 1 time and T occurs 2 times. Imagine this is the array we are having. So count array for S will become like this. Now count array for T will become A occurs twice, B doesn't occur, S occurs once, and T occurs twice. This is count array for T. So what we do is here we take two count arrays. What we do is we fill CS array, then we fill CT array. Once these arrays are filled, what we can do is we can compare both the arrays, and comparison should ensure that every character in CS of I should have count greater than or equal to corresponding character count in CT. If this meets for every character from A to Z, then we can say that all characters of T are covered in S. So if we take this idea, we call it, let's say, two count arrays. So we will have Sn to fill the first count array, Tn to fill the second count array, and 26 is the comparison we do for both the count arrays in finally to tell whether T is covered in S or not. And in this case, if you notice, we have taken two count arrays, so our space is 26 plus 26. Now, can we enhance this approach even further? Can we get rid of one count array and manage with only one array? What if we use only one count array and let's say we use that count array only for S? So we filled count array earlier for S, which is C of S. Let's go ahead and do that once again. Now, if we have count array of S filled, now when we loop over the string T, what we can do is we can decrement the count of every character. For example, first character in T is A. What we can do is decrement the count of A to 2. That means we have found one A already. Then go to second character in T, which is S, decrement the count of S to 0. Third character in T is T, so decrement this to 1. Fourth character is A, decrement this to 1. And fifth character is again T, make it 0. So as long as any count is not becoming negative, we can rest assured that this character has a matching character in S. So this way we are saying that every character that is there in T, we have matched that in S and we have found it. So this way, if we go, what improvement do we get is our Sn will be the time complexity to build this array. Tn will be time complexity to go over the string P and update the count array and also ensure that any moment, any character decrementing should not become negative. And this way we are saving additional overhead of comparing two arrays in the end. And this also optimizes our space to 26. Okay. Now here we used array for CS, count array for CS. We can also have an alternate approach where we use one count array, but this time we use count array for only t. Let's evaluate that idea also. This time, if we would have built count array for t, could we use that to solve our problem? Let's say we use count array for t. So here A would be occurring 2 times, S would be occurring 1 time, and T would be occurring 2 times. Now, if we have built this array going over second string, which in our case would be a smaller string, so we would spare less time in building this array because length of T is guaranteed to be less than or equal to length of S. In case it is equal, we are sparing the same time. Now, what we do is let's go over S. The first character of S happens to be A, so we decrement the count of this to be 1. Now, second character in S is B. That means that character B that we are seeing, that would have count 0 here. As long as any character of S has count 0 here, we don't have a problem. We will continue working. We'll ignore that character because, of course, that wasn't supposed to be a character in T. This is having 0 means it wasn't there in T. So basically, we will ignore such a character whose frequency in CT is already 0. Now, coming to next, which is A, you notice that here A's frequency is 1. Let's reduce it to 0. Then we move forward to C. C's frequency is already 0, ignore it. T's frequency is already 0, ignore it. O is already 0, ignore it. Oh, sorry, T we cannot ignore, my bad. T's frequency, make it 1. O's frequency, ignore it. D, ignore it. B, ignore it. S, ignore. Sorry, S, make it 0. A, ignore because it is already 0. T, it is 1, so make it 0. Then O, ignore it. L, ignore it. Now, if you notice, the check would be, in the end, the check would be that we should have all the characters in CT array becoming 0. Because only then we can say that a corresponding match was found. As long as this entire array is 0, we are done with our check. So if we go with this idea, we definitely saved initial time because we first built Tn array. But after building Tn array, we definitely had to go over string S also, which is Sn. But finally, we had to check CT array in total to check if it contains all zeros. So that has additional overhead. That is where it deteriorated. And here also we use space of 26. Now the same idea that we use here in approach 5, can we use the same idea so that we can avoid this extra step of checking our count array? In order to do that, let's say if we would have maintained a count, this is the matching count, whatever has matched so far, we would decrement it. So T has 5 characters, let's maintain the count to 5. Because CT has 5 non-zero values as of now. Total aggregate, if you do 2 plus 1 plus 2 is 5. So now what we do is, we loop over S, we check first character in S is A, A's frequency in CT array is 2. So let's decrement it by 1 and make it 1. And let's decrement the count also to 4 because one match is already over. The next character in S is B. B's frequency in CT array is 0. So let's ignore B. That means that character wasn't supposed to be matched. It is not guaranteed. Coming to third, which is A. Again, A's frequency reduces from 1 to 0 and count also reduces, that we have 3 more characters to match now. Coming to C, its frequency is 0 in CT array, ignore it. T, its frequency is 2, reduce it to 1 and make this 2. There are 2 more to match. O's frequency is 0, ignore it. D's frequency is 0, ignore it. B's frequency is 0, ignore. S is there, make it 0 and make this 1. A is 0 already, so ignore it. T is already there, so reduce that and make it 0. Now coming to O, frequency is 0, coming to L, frequency is 0. So if you see, we are done with S, But now we are not required to check our count array because we can just check our count variable that how many are yet left to match. And this would be a very good optimization that it would avoid doing that 26 comparison separately. So now here we built TN array, we looped over SN, and space we use this for CT array, so 26, but extra computation of 26 is avoided with the help of count variable. So we can say this is one count array for T plus one variable for overall frequency. So with this, we are able to optimize it. Now, all the approaches that we use from step number 3 to step number 6, they all can be repeated with the help of a map also. So basically, we can use two maps in place of two counts arrays. We can use one map for S and keep decrementing the values. We can use one map for T and keep decrementing its values like we did in count array. And we can, okay, in sixth step, ideally we will be at advantage if we are using one map. So here, let's me say 7. Ideally 7 also, it's like map in place of count array. So map will give one extra advantage. We ideally don't need a count variable separately. Let's see. If we build a map, what will happen now is if we build a map for T, let's say, so map of T would become something like it would say we are having A two times, we are having S one time, we are having T two times. Now, when we loop over S, the moment we have a match for A, we reduce its frequency to let's say 1. Then you have B, don't do anything. Then you have A, make it 0. Now, when it becomes 0, when frequency of any character becomes 0, we can very well go and remove it from the map. So now map will be left with two characters. So coming to C, T. Similarly, if we keep going somewhere, this will also become 0, we'll remove this. This will become 1, this will become 0, we'll remove this. In the end, if map is empty, if map doesn't have any keys, that would be a good enough validation that all characters are found. So here we don't need a separate variable to keep track of count. So this is one advantage that is there in map approach. So if we go with map approach here also, assuming map has time complexity of big of 1. Although with hash map, that is not the case. In hash map, average case we can say is big of 1, but we know worst case is big of n. But if we use tree map, then the time complexity is guaranteed to be log n. So either way, whatever map we use, for now, for simplification, I'm just assuming we use hash map and it has time complexity of big of 1. So the creating map for T would be Tn. Looping over S and updating the map would be Sn. And finally checking if map size is 0. Size is constant time operation on map. Then we can directly declare that this is working. So in this case, the empty that we are creating, worst case, if T happen to have all the characters, worst case will be 26. But here we would not write it as 26. We'll prefer writing it as Tn or 26. It is mean of that. So space complexity of map is a little better because whatever number of characters are there in Tn, that is what we are storing. Yeah. So this is a list of multiple approaches for solving this problem. Hope you enjoyed the learning. Stay tuned. We'll be having more learning shared in upcoming days.